Okay, we're going to try problem 13.7.8. Just right here. So there's 21 listed for the sequence of years, so 21 years in a row. First, find the median. All right, so how do we do that? Well, the easiest way is to just open in StatCrunch. And do a summary stat column labeled variable 1. And the median is 1480. So they want to know how many runs that, well, first of all, let's do this. The null is always that they're in random order, and the alternative is that they're not in random order. Okay, that's always the case. Now they want to know the test statistic. Well, if you look at the data, they're sequential and they keep going down. And the one in the middle is 1480. So there's 10 above and 10 below the median. The first 10 are above, the last 10 are below, and they go down. Well, they go down. In other words, the first 10 are above the median, the last 10 are below the median. So there's only 2 runs. So that would be the test statistic too. Okay. G is the so-called number of runs. Now, to determine the p-value, you would need the statistical analysis if the sample size is greater than 25. Because this is a small sample size. We normally don't determine the p-value. My guess is that it's 0, because if there's only 2 runs, that means we're going to reject the null, because it's obvious that they're not random. But anyway, to do this, we could go to StatDisk. So what I do is StatDisk 13. Now, if it's the first time you're ever entering it, see where it says download for Windows, that's what you would do, just download it. I've downloaded it previously, so I used the second one, and it just asked me for my email address and my password, if I can remember. There you go. Okay, so there's StatDisk. So I open up analysis runs for randomness, and I tell it, it was at the 05 level. Let me double check. Yeah, there it is, 05 level. So I go back to StatDisk. Number of runs is 2. The number of elements in both sets is 10, because there's 10 above, 10 below. Okay, so they don't give us the p-value here either, so we have to calculate it. So how do we calculate it? You have to go to, I have it all set up. This is called runs for randomness. See, this small sample is you just use G, and then there's a table, like we got the table here. If it's between 6 and 16, then it's usual, and you wouldn't reject. But if it's less than or equal to 6 or greater than or equal to 16 runs, now you have you're in the critical, so you reject. So we're going to reject. They just want to know the p-value. I'm pretty sure it's going to be 0, but we can't use anything from the small sample, so we have to go to the large sample, which says A is not equal to 0.05. So they're violating their whole principles. But that being said, we can still calculate it. So, excuse me, I need mu G. So N1 and N2 are both 10. So mu G is 2 times 10 times 10, that's 200. And it's divided by N1 plus N2, that's 20. They're both 10 again, plus 1. So that turns out to be 11. So mu G is 11. Sigma G, on the other hand, on the bottom, I would do the second square root. And I need parentheses for the numerator. 2 times N1, N2, that's still 200. That's the same number as we just calculated. Times 2N1, N2, that's 200, minus N1, minus N2, so that's minus 20. So that's 200 minus 20 is 180. So there's the numerator. The denominator is N1 plus N2 squared, so that's 20 squared is 400. Times N1 plus N2 minus 1, so that's 20 minus 1 is 19. Now I need parentheses for the whole fraction. Oop, too many parentheses, my bad. Okay, so, oop, that can't be right. Oh, I missed the parentheses. I see what I did wrong. I missed the parentheses for the denominator right there. So I'm going to insert a left parentheses. I was right. I needed another parentheses, but I forgot the other one. So 2.1764. I think 4 decimal places will be good enough. So now I calculated 11, that's mu divided by g, which is 2.1764. So you can see that's the z. The z is 5.054, and five standard deviations to the right of the mean, there's 0 probability. See, if I do a second distribution for the normal CDF, and I say 5.054 comma 10, that's the p-values. How much is in the tail? 10 represents plus infinity. Look at that, to 6 decimal places, it's 0. So my guess was pretty accurate, on the ball anyway. Wrong one. Oh, there it is, yeah. So the p-value is 0. There you go. So that means we're going to reject the null, and there is sufficient evidence to conclude that the beta is not random. It's contrived. Well, not contrived, but it's got a pattern, a distinct pattern. There appears to be a downward trend in the numbers of daily newspapers because all values above the median are at the beginning, and all values below are at the end. So that's what we noticed, and that's true. All right, so that's problem 13.7.8. And I'm going to go ahead and end this one, start another one for you.